Okay, and before, there'll be some late stragglers probably, as there always is. But in the meantime, I'll just explain a little bit about the training because this is a virtual training. This is Google Meet, what we use. We're changing pretty soon to Microsoft, but regardless of that, there are differences between all these mediums to present. So I'll be presenting via Google Meet, which you're all on right now. But just to let you know, I have two, as you see, I have two cameras. I have one on me. It's not very interesting to watch me. You're going to listen to me and hear the content, but watching me is not the important thing. I have the other camera on the stations, on the business lines, and it's not like I'm going to be there the whole time explaining the hardware that way. But a couple times I do want to get up and explain that. So I just want to explain about Google Meet. If you don't know already, there's a thing where it says pin, and there's a little pin. If you press that, that enlarges the screen for that. So when I talk about the stations and I'm going through the components, you might want to do that if you're interested. If you already know what I'm talking about, then you don't need to. But if you do, it's a good visual to see what we're talking about, because these virtual trainings are very effective because you guys don't have to travel all the way over to the Netherlands to get the training, and I don't have to go over there. But really, we all know live trainings are the best. I mean, if you're here, you get to see the components, the stations. We break them open. We go out to the parking lot. We have stations all installed there too. So it's really just an invitation too to say, if you're ever over here in the Netherlands, we have a global headquarters here in Amsterdam, and it's a great city to visit. So if you can do it on a Friday and then stay for the weekend. But if you're ever over, I invite you to a live training, where really not a training, but a workshop where we'll look at all the components. I'll stop there with the ploy on the training. I'm going to go into the PowerPoint now, to the slide deck, which means in Google Meet, if you guys are used to it too, means that's why I have two computers. I might have to come out of the training to admit other people into the training, so excuse me for that. But for now, we'll just get started with the PowerPoint. Okay, so again, my name is Joe, so I'm your trainer today. I'm an employee at EVBox, so I see some new EVBoxers also on the training today. So welcome to the club, and welcome to everyone else who's following the training today. So I'm an instructor here at EVBox. I've been here for quite some time, from actually the early days, as you'll hear when I'm talking about the business line. But I will stop there with my introductions. If you have any questions during the training, it's important that we get through all the content. But if there are questions and things aren't clear, please feel free to interrupt. There's also a feature here where you can raise your hand, a little signal that you can raise your hand. If you want to do that, please ask questions. We're hoping to have a few minutes at the end too, because a lot of these questions get answered later in the training, if you know what I mean. But feel free to interrupt if you need to. Okay, so we'll be getting started now then. Okay, and you see the title of the training, I just wanted to explain that too. I actually just added that before the training because EVBox BusinessLine is a legacy product of EVBox. It's existed from 2008 or something, so that's quite a long time ago for the EV market. We started with this station actually at EVBox way back then. Back then it was called a G1, We didn't call it a G1 because we didn't know there was going to be a G2, but of course there was, and so those were the original products. Now, just to let you know, from the outside with the cover on, the look of the station has not changed from the beginning. So these G1, G2, G3, and G4s that we're talking about look identical from the outside. This training is centered on the G4 version of this business line. We are going to talk about G3s as well because they are in the field. However, we do not produce and sell those G3s anymore. So this training is really focused on our G4 products and not our G3 products. But it's important to know as an installer, especially if you're servicing the stations, to know those differences between the G3 and the G4 and there are quite some differences, so I'll go through a few of those too. This is what the training is going to look like today. I won't go through each topic now because we're going to be going into detail on each topic. And don't be scared because it does seem like a lot. And I hate these trainings where you see the slide deck has 80 slides. And you're like, oh, where do I have to go for this? So I'll try to make it as entertaining as possible. As sometimes it can't be, but we'll try to do our best anyway. So we're going to go through and we're going to sneak in a break in there too so that we can get a cup of coffee. 2 hours is quite a long time to sit and concentrate on what we're doing. But this is the curriculum actually that we're going to be talking about today. And I'll go through each phase one by one. And just a quick introduction to the training itself, it's really, you know, we say an installation training, but we all know we have installation manuals, So if you read the installation manual cover to cover, you should be able to install this station very easily, But what we know and from experience and from practical experience, there are some things that aren't included in the manual. So we try to do that in this training, including a short overview of the EV market. This is quite a new market. So just to, and a lot of you, I'm sure, have the experience of being in the market. So I apologize for going under your level, but we do have to cover that to make sure that everyone understands how the EV market works. And then we're just going to get into the station itself. And in this case, we're only talking about the BusinessLine. You know, EVBox features a wide range of AC charging stations. This is our legacy product. We have over 100,000 of these stations installed all over the world. And that's what the training goes on, just the EVBox BusinessLine and specifically the G4. And we're going to talk about configuring it, not only installing it. Installing it really means doing the civil engineering and digging the holes and putting the pole in and putting the wires in. But we're going to talk about configuring the station. How do you get it working after you've installed it? Because that's the important thing. And then we're going to talk about the hub satellites because that's a very important part of this product. Our hub satellite configuration. It works in a lot of different use cases. Just to explain too, we're assuming anyone who's following this training, and I don't mean our EV boxers that are following the training for, for training purposes, for their own knowledge, but anyone who's installing our stations and following this training, we're assuming you're a certified electrician in the region that you're installing. You don't have to necessarily have a certification from EVBox. We do have those certifications, so if you do want one, you can get one, but it's not mandatory to do that for the AC stations. These trainings are made for that too. And of course, a basic understanding of e-mobility, but we'll talk about that later too. And emphasize that this is not a step-by-step training. How it says, first you do this, second you do that, third you do that, and if you follow it, my instructions step-by-step, you're going to do a good job. That's not the case. Along with this training comes an installation manual that we require everyone to read cover to cover for safety reasons as well. But you'll have this slide deck. So at the end of the training, you'll get the slides that I present today, and also the recording of what I'm saying here. So, okay, so let's get going. EV technology, just a short little part about the EV technology. One of the important parts of this is this difference between AC and DC charging. Today in the BusinessLine, our BusinessLine station is an AC station. That means that it takes AC current from the grid, from the electrical grid, and it doesn't convert it. It charges the car in AC. So the AC current is going into the car, which means, as we all know, to charge a battery, we have to convert that to DC first, just like your laptops or your telephones also have to be DC when you're charging. So that's done on the AC side. That's done inside the car on what we call an onboard charger. Okay, that onboard charger limits the amount of power that can come into the car. Different cars have different onboard chargers. A Nissan Leaf has a one-phase onboard charger, and most Mercedes-Benz have a three-phase 16-amp onboard charger. So that manufacturers of the cars determine what type of charging they want to put into their car. So that happens inside the car. On the left side, you see the DC charging. This, and you see that it's not to scale. If it was to scale, these DC stations, if you've ever seen them in the field, are huge. They're 2 meters or 2.5 meters tall, and they're also very big. Why is that? Because we convert the AC to DC in that station, and then we charge the car with DC current, which means that we can charge it faster. That means that, yeah, a lot faster. So in this case too, if we talk about sectors, what are we talking about? When you buy an electric car, you have a charger at home, and if your charger can charge your car within 8 hours, which is about the maximum that you want, because that's about how much you sleep. So when you wake up in the morning, you want a fully charged car. You don't need DC charging for that. Remember, DC charging is much more expensive. I say the big station, but those big stations are very, very, very expensive compared to an AC. So the AC is for residential use, but also workplace. If I have a charger at work, and that's what we're really talking about with BusinessLine. We have them all over the city here in Amsterdam, and also all over many other cities in the world. And what it is I come to work, and I also work 5, 6, well, you know, me, it's 8 hours, but some people less. You're charging your car when you're at work too, So yeah, most likely you only have to top it off. Yeah, sure. And then you go to the supermarket, and there's charging stations there too, which there are all over here in the Netherlands. Maybe not in the UK yet, but that is coming. However, when I drive to Paris, as we know, that's outside my range of my battery, and I do not want to stay on the highway charging for 6 hours on an AC station. So this is what the DC stations come in. Within 20 minutes, half an hour, you've charged your car fully, and then you can go to your next destination. So those are the differences between AC and DC. I don't want to go into too much detail because we're not really talking about that. There's many other, I invite you to go to our websites, and there's all types of information on this. Let's just talk about the power capabilities, because we're talking about AC input, AC output here with the BusinessLine. These onboard chargers that I talked about, that the manufacturers of the cars put into their cars, we have to kind of match those to say, well, what type of output do we want? What type of output do the OEMs want, the manufacturers of the cars? Well, they have a pretty standard line of those, and that's 1-phase 16 amp, 1-phase 32 amp, or 3-phase 16 amp, or 3-phase 32 amp. That's pretty much it. That's about the extent of it. There are in-betweens there, not exactly 32, but let's say, for example, a Tesla with 3-phase, and you're getting about 25 amps, so you're not getting that 22 kilowatts, but some of the Teslas can take about 18, and then you have also the Zoes and other cars that can take 22. So these onboard chargers, that's what we're trying to match here on our output of our station. So just to emphasize that, and also to emphasize, how do we calculate that power? Remember, the power is just the amperage times the phases and times the voltage. And that's you guys are all engineers, so you're all scratching your head saying, that's not actually true, and you're absolutely right, it's not, but it is a quick way of calculating the power of this, because otherwise you have to go through a pretty big manipulation of numbers. So remember, just the amperage times the voltage is our watts, and if we have 3 phases, we'll just multiply that by 3, and we get approximately these values coming out. The higher the value, the faster the car charges. But think about what I'm saying too, is to say, if I was charging a car with an onboard charger of 1-phase 16 amp with a 22 kilowatt station, I'm not going to charge faster than 3.7. So remember that restriction in the car is really what limits the amount of the charging speed. Again, this is a little off subject because this is about charging speeds. We'll talk a little bit about it later too. As far as charging cables go, we're really trying to consolidate this now. In the beginning, this was really 2 years ago. We had 2 different major cables for AC. A type 1 for the U.S. in the Japanese cars. Remember, U.S. and Japanese their grid network, at least in the time of the manufacturing of the cars, were only one phase. So their cars are only one phase. So they had a special one phase charging cable, and that's we call the Type 1. It's a smaller one. And you can see that there's not as, you only have for the neutral and for the one phase in the ground, and then of course the communication. And then for the three-phase cars, for the European cars, for the Mercedes and the Teslas, also is a Type 2. That's three-phase charging. And then we're not going to go to the Chinese ones. We're going to stay with these two because that's what we see in Europe right now. We still see Type 1, but I can tell you right now, Type 1 will be phased out. So even the cars that are charging in one phase will be using this Type 2 cable, and that's only dimension-wise. You see that one's bigger than the other. That way you can charge with a Type 2 cable, a one-phase car or a three-phase car. And of course, that makes a big difference. Then when you're looking for a charging station on an app and you have a Mitsubishi Outlander with a Type 1, now I don't have to find a special station. I can go to any Type 2 and I can charge there. I will stop there. Another important part of the cable is not just the charging and the power that goes in, but the communication with the car. And that's what I'm going to talk about now. Now, you're installers, so you don't really get involved with this. That's why this is kind of an addition to it. It's really nice to know. But what we do is we have a little, there's a little red wire, that copper wire, very small copper wire that connects the cable with the car with the station. And all we do is we send a signal. And I won't go into too much detail here, except for the fact that when that signal comes back from the car of 9 volts, it tells the station that there's a car on the other side. It's a car that follows our OCPP protocol. That's the protocol we use. And it's saying we're getting ready for charging, and they're communicating right that. The squiggly lines, the voltage there, that's a sine wave voltage, that's telling us how much power that we have to offer. And then the car asks for a certain amount of power. When everything's ready, when they're ready to charge and everything's safe, remember safety is number one, then it drops to 6 volts, then we call that state C. And then our LED ring will be blue, charging. That means our relay is open. Now, it's very, very important because that's the only time that the relay is open and that we're charging at full speed. Otherwise, it's only the electronics that are working in the station. So this opens the relay, and of course, as you know, it has to be all the checks and balances have to be there, has to be an authorized rider, has to be safety mechanisms in place, etc. During the charging, when it goes to blue, it's charging the whole time. During the charging, the car or the station could stop the charging for various reasons. And that's, you'll see, all they have to do is if the car wants to stop the station, it just sends a 9-volt signal back and we say stop. It could be overheating, could be full. In this case, it's not full because we see that he resumes charging after. So it could be the fact that it was maybe overheating or something. Or remember, the station, we could have stopped the station too, as far as a charging station goes for load balancing or something like that. And you see that he resumes after that. There at the end, yes, that's when the car's battery is full, it sends back a 9-volt signal automatically, and says, I've had enough, stop. And then it goes to yellow. When the user comes back and sees yellow, they say, oh, it looks like my battery's full, and then they can disengage. As soon as they disengage, then it goes back up to 12. There's a lot of information about this on the website too, so I'll leave that to you to look it up if you're interested in it. Quickly about the charging speeds, we've talked about speed of charging, very simple calculation, very raw, of course, this is approximate, because of course temperature has something to do with it too, and then we talked about the onboard charger. So here on the left, I have a Tesla with an 11 kilowatt onboard charger, charging at 11 kilowatts. If he was charging with a 22 kilowatt station, it would charge in the exact same time, 11, because that's the configuration of the onboard charger in this Tesla. On the right is a Mitsubishi Outlander, very small battery, one phase, 3.7 kilowatt charging. that charges in 3 hours, because the battery is very small, so it doesn't need much. So that calculation is really just the capacity of the battery in kilowatt hours divided by the power going into it. Remember, that's not the power of the station all the time. It's sometimes the power of the limiting factor of the onboard charger, and reversed, it's the other way around. Just keep that in mind, especially if your customers are asking. Sometimes you do have customers say, why am I not charging fast enough? That's a common question for people, especially new EV drivers. And another thing to make you aware of, if you're not already aware of, is also with DC, that the 50% of the charging, the time-wise, takes place, covers 80% of the battery. So that means that the last 20%, when the battery's almost full, it takes almost as much time as the first 80%, because of course they don't want to cram all that into it. So customers would call complaining about their charging speeds, but you'll ask them, how full was your battery? It was 75% full. Well, that's common at that state of charge, as we call it. Okay, let's keep on going, because now we're going to talk about the BusinessLine itself, and get to the real nitty-gritty of the state of the training. This is our BusinessLine, and like I said, that picture on the right could be a G1 or a G2 or G3 or to G4, because inside is the only thing you're going to see different. But these are the features. Now, these features that you see here, and I'm not going to go through every one, these are features that have to be in almost every charging station. There's not many differences. Us, EVBox, our competitors, they all have to charge between 3.7 and 22 kilowatts. Why? Because the car manufacturer said that's what our onboard chargers are, so that's what we want. So most of our competitors, all of our stations, you'll always see this 3.7. But you see a lot of different things in there too, and I'm just going to bring out a couple and that are new to this G4 as opposed to the G3, and that is the Wi-Fi. And the Wi-Fi is something that helps it be connected to the internet, which is a very important part of these devices, is that they're attached to the internet. Bluetooth is another thing that we're going to talk about. This is another great feature that we've added that we didn't have on G3, but we have G4 now. And this Bluetooth this is the one that you as an installer use to configure the station, so you don't have to call into support. You don't have to do anything in the station. It's done in an app after you've installed the station. It's no touch, and it's very intuitive the way you go through it. I hope so anyway. We'll take a look at that later if you've ever used it before. But for the rest, you see that there's all these are pretty standard features in our line of AC stations, and like I said, not just our line but also our competitors for these G4 stations. There's new ones coming out. We're coming out with new products all the time. Our competitors too. So if you're ever interested in that too, you can look on our website of all our new devices that are coming out. The mounting options are really not limited, are wide open. So most of these stations are put onto a pole. That's a very common thing here in the Netherlands. Why? Because we started with these. And when they talk about any charging station, they talk about a charging pole here, because of EVBox, and we're a legacy product here. But you can get it on a wall mount as well, and a double-sided, one-sided. You can get it with a cable or with a socket. Most of them are sold with sockets here. So just to let you know. And then your own mounting options too. We have a lot of customers that do their own mounting options. So that's also possible, and we work with our customers or our partners to develop those. Now, in the installation itself, before we get into that, I do want to talk a little bit about G3 and G4, okay? Because this is also something that I added after, because what I was told to do is to develop a G4 training for installation. But I know installers that are installing our products are also usually out in the field servicing our products. So I want to make you aware of these differences between the G3 and G4. And this is where I'm going to get up and show you on the stations. If you look on the if you pin that where these four stations are, I'm going to stand up now and get to it. We have on this side here our G3 stations, and this is a G4, and these are G4s as well. Just to give you an idea, these don't mix and match. So if we have a hub satellite, where we're going to talk about later, you can't attach these two together. They're totally separate. So these components are completely different. From the outside, they look the same. If you do open it, what you'll see in the G3 that, and I took this out so that sometimes it's pretty far to look. There's a connector like this, and you'll see it with the different colors here. And this is an RFID reader and used as a connector, and there's all kinds of wires that come out. And this is the modem that it goes. This is G3, G3 that you'll see in the field. The G4s are very easy to identify when you have the cover open, and that's this device here has all these components inside our control box now. And we did that for a very good reason, because we found servicing this, sometimes the installers would actually make it worse than it was, because there were too many different wires. So now what we do is when you're servicing this pole and it's a G4, you'll pull this whole thing off. Now that's how to identify the different stations visually. We'll talk about identifying it in the part number as well. But what's important to know is that they don't go together, so that if you see these two, first of all, if it's a G3 with that modem separate and the RFID reader separate, that you can't configure the station with the Bluetooth. We don't have a Bluetooth in there. So if you need to configure the station or you have any questions about the station, then you do need to call into our support, which isn't a problem. But for us, we don't like to have all those calls in, and you guys don't want to have to call. So that's why we've developed the G4 with the Bluetooth. But the G3 is still serviceable, of course, but then you have to get in touch with us. And we have a separate, of course, support network there in the UK. So you'll call them, or if it's in Ireland, it might be another number. But that's how you service the G3s. The G4s we're going to talk about today. And if you look at these components, we're not going to go through them, but you see that some of these changes from G3 to G4 have to do with the safety, with the electrical safety in it, or the communication, or we added Wi-Fi or Bluetooth, or we changed the configuration of the control box as I showed you there. So there are always reasons that we make these changes. This G3 to G4 was a big change, but not as big as our change from G4 to G5. We're not going to talk about that today, but of course, we've come out with our line of G5 stations. If you're interested, you can look on our website. If you want, there's trainings for that as well. So we're not going to talk about that today. This is the installation manual for EVBox BusinessLine. This is the G4. There's a G4, of course, special version. And you see down here, it says Part A, Manual Part A. We also have a Manual Part B. Part A is a typical manual with all your, instructions in these little tiny print that, we all have to admit, not everyone reads from cover to cover, although it's important to do. But we also have a version of this type, the Part B, that I don't show here, that has more diagrams than words, like sort of an IKEA manual, where it shows just really pictures on to do it. So Part A, Part B, and a training should be pretty easy after that. But that's why we're here. These stations sometimes aren't the easiest to install. So I'll be very honest with you to say that. We're going to talk about why in a second. But this, of course, you need to read, especially with what tools do I need? What type of safety precautions do I have? How do I troubleshoot? I'll tell you how to troubleshoot here, but it's nice to have a guide there when you're on site. Okay, and this is what I was talking about. I'm just going to quickly get out of the thing because I'm going to show you a little video of an installation of the BusinessLine. It's only a single a double line, but a single. It's not a hub satellite. It's just one of my colleagues actually doing this, and he's going to show you how easy it is to install. No, and again, of course, with movies, it's always easy to show. But let me just put this video on. There we are. Okay, so you can see how easy it is to install. No, seriously, of course, it is good to watch something like that because I myself have installed several of these, but it's not my job, so I don't do it all the time. But I know people that do this all the time, and I've been there too. And yeah, as we see in the video too, a lot of the work has to do with the civil engineering of digging the wires in, putting the wires in with conduits, and setting everything up. We don't talk about that here because that's just like any other equipment. How that has to do with the installation of the station. So we're going to kind of go through that. But of course, you need to do that. So I don't have to tell installers how to prepare for civil engineering because you guys do that on a regular basis, whether it's a washing machine or whatever you're setting in. But of course, these products are outside, so you have to take that into consideration. If you don't know that, then you follow the guidelines that we have. So that's the civil engineering. I'm not going to talk a lot about this, but you see too is as someone also that worked in this company in the support department too. I used to help our installers a lot years ago when here in the Netherlands, and so I know what the pains and woes are from doing these installations. So let me just talk about those a couple times. Just on that video too, you notice if you were attentive and you were listening to my early explanation too, you see that was a G3 station, so a little bit older station but the installation is exactly the same, so you shouldn't have to do that. Another thing you notice too is that it says 140 centimeters. 140 centimeters used to be the ideal height for charging a car. No, we've lowered that to 120, and you'll see that in all our manuals now because of handicap access. We find that 120, if you're handicapped, if you're in a wheelchair, it's easy to do, and if you're standing, it's also easy to do. So we've added that. It's an industry standard these days as well. But another, as you see too, another thing too with the station, where do the cables come in? Yeah, they come in through the pole, underneath the pole from the ground. And you see, yeah, he made it look easy, but it isn't, Those stations are pretty heavy, even if you're a big, strong guy. These are double-sided stations. I don't know the kilogram weight on that, but it is hard to put that over your head, and you have to put it onto the wire. The wires have to fit through, and you see also in that diagram, in that film, that it was a single wire, These stations take double wires. We do have a version with single wire. We are going to talk about that later because it's very important that we don't mix those up. But this, you see, was one single wire to feed two different sides. That's a special setup. But most of these stations have two wires. And if you have a two-sided 22 kilowatt station, you need two wires because we don't have big enough wires for that. And I can tell you it's difficult to get that over your head. So if you're not experienced, I would say try to do it with two people. It's much easier. I've done that with and then of course, putting the tape around the wires like that, because feeding it through that station is difficult too. It's not much room, especially if they're 32 amp cables, because they're much thicker, of course, and they're 3 phases. So just keep that in mind too when you're installing it. But now I'm going to talk about the opening and closing the cover, because this is also what I used to get a lot of calls about too. But just to let you know how we use hex screws for this. And remember, we do this for a reason. This isn't just to irritate installers. We do this for a reason. It's for safety, of course. We don't want anyone coming over to a charging station, high-power charging station like this, and with a screwdriver and just being able to take it apart, because that does create problems if it's easy to take apart. Anyone can get an Allen wrench, so anyone can take this apart. But if you see where the two places are for the Allen wrench, that's where those two red arrows are in the middle diagram. Those go back against the station, so that's where they go. We provide this Allen wrench, this hex screwdriver, 5 millimeter. We give that to you when you get it, but again, that's not the handiest thing to use because sometimes you don't have enough room to get up in there, and you can't see because they're deep in there. And if it's dark, you can't see. So it's good also to have a nice torch lamp when you're in there doing it. After you've done this 4 or 5 times, it's very easy, but the first few times it is difficult. Just as a recommendation, and we did this a lot too, a lot of our experienced installers use on the right there a socket wrench with an Allen wrench. and there's various lengths, so you could have different lengths, and then you could always, much easier to do that way, much easier to get in there with one of those socket wrenches. But if you look on the right side is a little film about, it goes from the top down. It's not hard to put on, but you have to make sure that it is put, the screws and the screw attachments have to be lined up, of course, so sometimes it's hard. And just take into account that sometimes there are problems with the screws, so just keep that in mind. Do your best when you're trying to do it. Call support if you're really struggling with it, because they know about this too, and they know what to tell you. When you're feeding the wires to the station, because this is in the business sector, not necessarily a residential station where the source and the station are pretty close to each other. Usually here we have some distances. So what we're recommending for, if, regardless or regardless of the distance, what we're saying is a 2.5 millimeter for 16 amp cross section, square millimeter, and 6 square millimeters for a 32 amp wire. But of course, our BusinessLine can take up to 10 millimeters. So that 6 can be up to 10, depending on how far it is from the source. So these are good up to 40 meters from the source. And of course, a good way to measure that is to make sure that you're in that vicinity of 10%, plus or minus 10% of the nominal voltage. We used to have this at 5, but we realized that there's too much fluctuation to make that strict, to say if I'm measuring at my input terminals 10% or 10% less, we're still okay, but we want it to be within 5. And of course, if you're outside that range of 40 meters from the source, then you have to make that calculation of what diameter you will need to get this power at the input terminals, and we can take up to 10 millimeters, so you know. Upstream protection. Inside the station, we have a protection for overcurrent. We have protection for RCD, so for leakage as well. On the AC side, 30 milliamps for AC. And we also detect in the station DC leakage. So upstream, we still require an MCB, and that's to protect from both sides, the cable. And so upstream, we want a type C MCB, 4-polar if it's a 3-phase system, and of course 20 or 40 amp depending on your thing. But that's required for each connector upstream. Okay, now into the nomenclature of the stations. Now, just bear with me for a second, because we have what we call station IDs on the station, and those are very important numbers. And why are they important? Well, they're important because if you're contacting us, we identify the station with the station ID. That station ID is not what we're going to talk about here with the type number, SKU. This includes the station ID, includes the customer, how many, all the legal matters that have to go with the station as well, not just the specification. In that station ID, if you call into our support network, they'll be able to give you the type number that I'm going to talk about now. But it's also on the station, it's also in the paperwork. And what this type number does, and there's different synonyms for this, so we'll call it a type number or type, or SKU, or article number. And what it does is that identifies our station as for you as an installer. It identifies what type of station you have, not the owner, but just specifically the technology behind it. And this is how it works, and it works the same for all our stations. We have similar type guides with this. The B, of course, stands for BusinessLine, which means that we know that this is a BusinessLine. That's important because the only way to know that is with this article number. The station ID number will not give you whether it's a BusinessLine or not. We have other AC stations like LV, if you're familiar with that, and of course that's going to start with an E, which is a totally different station. The 3 is a 3-phase, means that it has a 3-phase input and output. So that means I can charge in 3 phases here. 16 is the amperage that we have coming in, that 2.5 millimeter 16 amp, in this case 3 phases. And then our 2 that means there's 2 sockets. So that means a double-sided station. But just to go back to the 3 and the 16, remember, here is an 11 kilowatt station. Now, that's how we actually name it. If you multiplied that 3 times the 16 times 230, which is the volts, always, you'll get yeah, 10,800 or something watts, which is rounded to 11 kilowatts. Okay, so the 2 means it's a double station. If it's a 1, it's a single station with one connector. If it's a 0, it's a good one. If it's a 0, it means there's a cable attached, and then later in the number you'll see the length of the cable and whether it's a type 2 or not. Most of these business lines are with sockets and not with cables, so you'll probably always see a 1 or a 2 there with that. This E1, very important. This is the G4. This tells us it's a G4. If you don't see that E1, and if you see any of the other numbers, remember, I'm going to give you where you can find all this documentation too. These guides, you don't have to memorize these things, how these things are you can follow. And then if you see something that's not an E1, oh, I wonder what it is. Yeah, then you can look it up, of course. But if it was a G3, it would be a 5. So E1 doesn't only tell us that it's a G4, but it also tells us it's the hub. And we're going to talk about this later in hub satellites, but we have 2 different versions of this. One we call the hub, and one we call the satellite. The hub is the E1 on G4, and the satellite's going to be E5. Now, when you're installing hub satellites, that's very important to know because the hub is where you start. That's going to be on either side of the string, and we can't do this in star formation. We'll talk about that when we talk about hub satellites. Let me just continue with this. So that G4. And these other numbers, they're proprietary, or they have to do with the cable or some safety, but I won't go into that because you see that those are all listed there. You don't have to memorize these things. But those first 4 or 5 digits are really important. Most of our installers, when they see those numbers, they know exactly what they're talking about. They're saying, oh, there's the E1, so I know that's the hub. But we'll talk about that too later. Now, I talked about the installation video that I just showed you, and that it only had 1 cable. Like I said, most of our double-sided stations take 2 cables, and they have to be secured separately. And inside the station, they're secured separately. So let's take a look on the one on the left side, which is our most standard version. And this means that I have 2. Remember, the output is going to be 16 and 16 on both sides. So if it's 3-phase, it's going to be 11 kilowatt and 11 kilowatt. So here I have 2 cables coming in, 16 amp cables, and I listen to the both sides. That's very simple. But we do have a version of this which allows you to use 1 cable. But that cable, of course, has to be 32 amps, not 16, because I need 16 on both sides. But inside this station, we secure it at 32. And then we less it to the different sides so that it's safely done. The one on the left, if you try to put the 1 cable on the one on the left, it's not going to work. And worse than that, it might work, but it also might not work, and then you'll be confused. So a lot of people make these confusions. This has to do with the part number. So and again, you'll have these slides, but it's important that we know. We notice that this gets overlooked a lot. If it's a 9 after the E1, that means it has that 1 cable. And if it's an 8, that means it's the standard version of 2 cables in there like that. And I don't show that. I had another slide where you see that that's protected. Of course, this one has a 32 amp breaker in here, and this one 216. So we can't mess those around and switch them like that, just so you know. Very good to know. And this is just showing where that is. That's that number here should be a 9 or an 8, depending on what it is. Okay, listen. What time is it? We're going to take a little break. We might as well do that now since I've had these in. And you see that this is from the last one here. So what we'll do is we'll take 10 minutes. We'll come back, and I'm assuming that everyone's on the English time system, so that it's, for me, it's 10 minutes before 11, but for you, it's 10 minutes for 10. So let's take 10 minutes. Get up, and I recommend this too as a trainer. It's really good to do. I did this with the kids too. Get up. Go get a coffee, walk around a little. You always refresh your brain a little bit when you're doing that. I'm going to do the same thing, and we'll come back at 10 o'clock and resume the training. Thank you. Hmm.
Hello, hi Joe.
Hi.
Actually, I have a question, a basic question regarding proximity pilot values. Like we have three resistance values for three cable currents.
Yeah.
So, is there any calculation, like any specific voltage divided by resistance, so it can understand this is the current or
Yeah,
what's?
sure. Certainly. And we had a slide about, and let me just go back on the slide because I have it there, but I didn't talk about it. So I'll explain it that way, huh? So
Right.
if I go back here just a little bit, let me see where
Because
we
yeah,
are.
I have seen this slide before also, but I didn't know the calculation, like what is the voltage passing in the proximity pilot.
Oh, it's not really a calculation. Just a measurement, huh?
Okay.
On both sides of the cable. So if we have a cable station, huh, that's attached to the side's attached to the station, and then it's a cable version that you put into the car. Then we have a resistor on one side. If it's a loose cable, then it's on both sides,
Yeah.
and it has resistors in it. Huh? So in the proximity pilot, we just measure the resistance. So that wire doesn't even go into the cable. It just goes very shortly, maybe a couple inches into it, and then it's a resistor, and it sends it back, and it measures that resistor. And if we have 680 ohms, then we know it's a 16 amp cable. 220 ohms, etc. We How do we measure that? We measure that using our debug. Huh? So it's our software that can measure that, and we'll know what type of cable it is. Huh? You
Right.
can't measure that like externally, so it's something that has to be measured by the station.
Okay, right. As I have seen in my past experience, like I saw there is a resistance being installed inside the connector for the PP port
Yeah.
just to know the current. But if you want to check the calculation, like if there is a passing of 12 volts or divided by certain resistance, so it should be this current. So it won't be like this. It's the standard value, we can say.
Right. Yeah. When we're talking about the resistance for the proximity pilot in the capacity of the cable, we're talking about
Yeah.
resistance measurements. Huh? But I think I know what you're talking about, because when we're talking about what we're talking about here, pulse width modulation, huh? Then
Mhm.
we have a value where it's a calculation, huh? And then we're saying to the customer 0.53, huh? We have to multiply that by a factor, and actually what we're saying is 32, huh? But that's all also, it's kind of cryptic, but it's really just saying what is my maximum. And if you look at that top of the slide, huh, it says the control pilot, and it tells what the power of the station is, huh, what the
Yeah.
power of the EV is asking for, and then translating that, and then there's a calculation to get the actual amount of amperage that's asking for. That might be what you were thinking about, but in the case with the proximity pilot, it's a measurement, huh? So we measure that in our debug function.
Oh, right. Perfect. Thank you.
Yeah, you're welcome. It's like I said, it's interesting. These all, just to explain it too before we get started again. Um, these stations, just so we all know, huh? These stations are meant to be supported remotely, huh? So we have a support department that has access, and we'll talk about this too very shortly, because you guys don't have that access. But it's nice to know that there is this access, huh? So that means that if I'm a support person, huh, I can look into our what we call our station logs, and I can see anything that's going on with the station, huh? So it tells me power meters failed, huh? It'll tell me what type of power, what type of voltage I'm getting per phase when I'm charging, huh? How much voltage, how much amperage, uh, anything we need to know about the charging session is the sensors throughout this whole station, huh? That measure all these things for us. Huh? internally. So when our support people, because remember, you're installing the device, you're going to get it to work, you're going to walk away, and this should work. Devices like this work for years without problem. But after years, there could be a problem, so then you need to service it after that, and then you go back, and then you need to know these things. But let's continue with the training, because we're going to talk about all these things as well. Whether or not, whether you're installing the station or servicing the station, this configuration app is really handy to have, because then you don't have to open the station or measure anything. It can give you those measurements aside. So let's talk about this. This is called the EVBox Connect app. Now, this is free to download at any Google Play or an app store. Anyone can put this on their phone, huh? So yeah, then we say, well, what's the security behind it? Well, you'll see it if you've ever used it, huh? That you need to put in a security code when you're using it, huh? Which tells us that you're the owner of the station, or you're installing for the owner of the station, because we don't want these to be used for, that anyone can use them, of course. So what can we do with this install app, huh? Well, we can rename the station. So when you're installing it, if you're installing it for a customer and you're not sure what they're going to name it, you can name it temporarily something, huh? Saying Johnson's charging station, or this parking garage charging station. The owner can always go back in and change that again. But a lot of the times when it's a commercial situation, semi-public, you're going to probably maybe name it saying, Johnson's parking garage left side or west side or something like that. So you can name it anything you want. Those can be always changed, so you can change them anytime you want, but it's really just a reference for yourself. You connect to a Wi-Fi network. Like I said, connecting these stations to the Wi-Fi, to internet is extremely important. They all have to be connected. And I know years ago it was always, oh, why do we have to be connected? It's only a charging station, etc. We all are aware that the importance of these stations being connected. And I was just mentioning it with the support. Remotely supporting these stations is the key to being successful in this market. So connecting to the Wi-Fi is, remember, there's a SIM card in here as well, huh? So there's cellular communication, but as a backup, we also have Wi-Fi, huh? So you can use both or one of the or the other, huh? You can also change this to a plug-and-play situation. So in other words, if you want to test the station, you can quickly test the station by switching it to auto start, what we call auto start, which means that you don't need authentication to do a charging session, and you can start a charging session just to make sure everything's working for the installer. You would switch it back after that, because then the customer has a station that's not secure. You also set the maximum current in the station. And that's not always the station maximum output. Remember, if you're, and we'll talk about this with hub satellites especially, but if it's, say, a residential, it's one station, it's sometimes limited, depending on how much power the residence or the establishment has, to say, well, it's a 32 amp station, but we want to limit it to 25 amps. You can do that with these functions, so that it limits the charging power as well, but it means that you're not going to trip your circuit breakers if you're using too much power. You're also able to change the charging management software. I was talking about this being all connected to the to a back end on a platform. So on the internet, EVBox has our own platform. Most of the stations you'll be working with will be attached to our backend, but there's a lot of other backends in the world, and all our stations work on a lot of the other backends. So you're able to chain in. I'll just throw one out because I know it's an English one, and that's Genie Point is a backend. That's our competitor, but we're not competitors really. We all want everyone to be happy. If our stations are on a competitor's backend, that's fine. We're qualified for that backend, and we're qualified from almost all backends. Now, it's a drop-down menu that you have for this third-party backend. If you're getting requested from your customer to put it on a backend that's not on the list, then you contact us, and we will do the testing needed if it's possible. It does have to pass requirements, but most of them are acceptable with our stations, because we all work together That's what we call the OCP protocol. If you follow the protocol, most likely you're all able to work on any backend, and same thing is vice versa. Huh? We have a lot of non-EVBox stations on our backend as well, of course. That's the market. That's the way it works. If you get into trouble, there's frequently asked questions, and they're actually pretty good. I've used it a couple times. I don't like those frequently asked questions because, like, every time I use them, it's like, it's not the one I'm looking for, huh? But this one is really pretty extensive, and you can search. It has a search function on it. But if you get into trouble with this, remember, you always call support. They can lead you through that. But it's a very intuitive app. I don't think you'll ever have problems with it. But what we're going to do, before we do that, I'm going to show a little video of that. So you don't have to hear me talking about it. But let's talk about just quickly on the maximum current, because this is important. If it's a single station, huh? Why wouldn't I set it at the maximum of the station itself? Well, sometimes it's limited at that residence. I say it's a residential station, and they have a total of a certain amount of amperage. And then if you add that plus 32, it's going to be too much. Then you're going to go over your limit. So then you're going to need to set that to a 25, which means that you're going to be, even in peak hours when I'm using all my appliances at home, I'm not going to trip any circuit breakers. So that's a reason that you change that. On the multiple stations, on the semi-public, when we're talking about the hub satellites, that maximum current is going to be all stations combined. So that's important to know. Huh? When I'm configuring it, I'm configuring actually the hub on a hub satellite. Huh? And when I configure the hub, I'm configuring all the stations together. Huh? So I want the total maximum current there. Huh? That could be over 200, 600, 230 amps or something like that. Remember, because you could have up to 20 stations there, so you could have that times that. But we'll talk about that with the hub satellites as well. And you see here, back end, you can switch it to the back end. I talked about that already. Phase rotation, we're going to talk about as well, but this allows you to do phase rotation in the system as well. But we'll talk about some of those differences because I don't necessarily think that you should be doing those. But you do the phase rotation, what we'll talk about later. Now, let's just take a look at this this little app. And again, this is an opportunity for you to take a little break from my voice. And we got a nice little video explaining this Connect app. A nice young girl's voice, and it's really pleasant with music in the background. So I'll shut up and let you guys follow that.
Welcome to the EVBox Connect user setup tutorial. This video applies to stations connected online to a charging management software. To proceed with pairing via Bluetooth, press the Start Pairing button in the app. Then select your charging station. Now, enter the security code to authorize the station. Once the station is paired to your phone, you can rename it so that it can be easily recognized in the future. To connect to a Wi-Fi network, press Charging Station Settings and then follow the steps to select the correct Wi-Fi network. One way to control who can start charging is to set up Swipe to Start, which requires users to present a valid RFID card each time they want to start charging. If Swipe to Start is enabled on a station connected to a charging management software, then every card swiped will be checked against the backend for authorization. You can also use EVBox Connect app to set up online auto start. This feature allows for a card or key fob to be saved in the app and used to start a charging session. To enable auto start, add your charge card by entering the RFID code of the card. If one of the charge cards is no longer used, you can remove it from the list of cards in the app. Now you are ready to use the auto starts function. It's important to note that with auto start, charging will start automatically and the selected charge card will be used for all transactions. If you have any problems, check out the EVBox Connect FAQ in the app. Please go to the top right corner and press on the information icon to find the FAQs. It has answers to questions about the most common issues with Wi-Fi and Bluetooth connections. Congratulations, you're all set up.
Okay, so that app is connected to the back end, huh? So I was saying you don't have access to the back end per se, but in order to make it work, there's an API that connects these two. So when you do something in the station, of course, it changes it in our back end as well, huh? So I just wanted to talk about the back end for a second because this is what our support people use now. In the future, you'll probably see that we're going to have partners like you guys, the people that are either reselling or installing our stations, also supply this support. But for now, we have these support networks all over the place, and England is a big hub for our support network. But you call into actually EVBox when you call into our support department, and we have access to all these stations on our CMS. So remember, too, that if it's on a third-party backend, that's not our CMS, then it's difficult for us to see anything. But in that case, our competitors will send us the logs if there's something wrong so that together we can solve these problems, because that's really important. We don't want to get the customer involved with competitiveness. So what do we do with these? Why does it have to be online? Again, it's accessible anywhere. So we have not only support people, we also have administrators. Remember, when people are using this equipment, it's not free. They're paying charges. They're being charged for their electricity they're being used. So tariffs are on these, and the owners want to get paid for their electricity. This is all done automatically via the internet. So there's all kinds of ways of doing that, of course. So these have to be connected to the internet. That way it's all automatic. But also, for me, I think the most important part of this remote access is the support network, because for approximately every 7,500 stations, there's a lot of stations, you only need one support person, because, like I said, we have an uptime, regardless of which device it is, we have uptimes of about 99.7%, which sounds really great, but when you're talking about 100,000 stations, that means there's stations that aren't working, and we don't want that, of course. So if I'm a support person, and I get on these networks, I can get up in the morning, 7 o'clock, I start my day, I can see whether something's going wrong on any of my stations. And then I'm proactive and I go in and I try to solve it before hitting. This isn't support training, it's not support training, remote support training, but that's what we train our people to do, to look for these things, to look for problems that are happening in the station, and to intervene before even the customer knows that something's going on. Are we perfect at that? No, but we're getting better and better at it. And without this remote support, it's impossible. But of course, another really important thing is our firmware updates. Just like your computers and your telephones, we do these very regularly in order to do this, because, of course, our OEMs, the manufacturers of the cars, we have the same type of software and firmware that we talk to each other. So they change their firmware, we change ours. We have new features. They have a new car out in the market. These things are updated regularly. We do this all via the internet in bulk, so that we don't have to, have any downtime from the station. So there's also an important factor in keeping why it's on what we call our charging management software. And again, EVBox is a big CPO in this. We have about 100,000 stations on our network, the biggest in Europe. But we also have a lot of competitors, and a lot of very, very good competitors as well. We all do about the same thing. We are one of the biggest. But again, we have like the versatility of saying you can use other ones. Again, we all have to follow this OCPP protocol. In this case, it's 1.6. We're moving to 2.0.1, but I won't get into that either. Testing the station, okay, this is important too. When, like you saw in the video, when you're done, it's important to make sure that you've tested the station. And you do that, you can do that in two different ways. First of all, I just want to explain this activation process. This activation process is really something that has to be done before the station works, and it's not a technical thing, it's a legal thing. So that means that the owner of the station that has purchased the station presses yes, I agree to the terms and conditions, and that's just an email that they get, but it has to be done. If the customer has not done that, you can do anything you want to the station, it's not going to work, I can tell you that. So that's why it's important that customer interaction, that this information's there already, so that you know that this can be activated, because you can, like I said, you can do a fantastic job installing the station, and then when you go to test it, it's going to flash red because it's not activated yet. So that's an important part to know about. When you do test it, you don't have to have a car there, but it is also, you can, any EV should start on those stations. You see in the video, he did both. He uses this test box, what we call test box. This is also an industry thing. It's not necessarily just EVBox, although we do sell these and we make them ourselves. So this is the test box that simulates that car, that gives us that 9-volt signal back to say I'm a car. They just kind of make believe they're a car because that control pilot is telling us that it is a car and it's following the protocol. And we can actually start a charging session. It can actually go to blue, so we can actually open those relays, or I'm sorry, open relays. It's closing the relay so that the power goes through. But actually, when you're testing in the test box, no actual power is going through it, but the relay is closed. So it's kind of a safe way to test it. But if you're think about installing a hub satellite with 16 connectors, yeah, you don't want to drive a car to every single parking space to test it. So these test boxes are really handy. If you're testing a station that has a cable in it, then we have a different one. It's a cabled version, male, female, whatever. But you see these all have specifications to them, and you can order them. If you don't have them in your line, you should, because if you're testing EVBox stations, it's important to have. Now, testing itself is very simple because you're just saying, all I want to do is get a charging session going. And that doesn't mean you have to be pulling kilowatt hour readings off, although that's helpful too, because we also want to know that the power meter is working. But there's no way of you telling that anyway. Only the support could really see that. So when you're going through this testing procedure, you're really just playing the customer, saying, I have a new car and I'm going to see if it goes to blue, I'm fine, and because it will never go to blue if there's something wrong. Anything that's wrong, safety, activation, the card's wrong, whatever, won't go. And what you're going to see in that case is you're going to see a flashing red connector, and that's just telling you there's a communication problem, not that there's anything wrong with the station. When you get a solid red, then you'll know that there's a defect in the station. The chances of that happening on a new station that you're installing is very, 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 very low, although it does. I mean, there could be a manufacturing defect when it comes in. But sometimes after years, a power meter might fail for some reason. And then the station won't work. It'll say, and it'll just be solid red. Now, this is the trick. What's wrong with it if it's solid red? Well, if you call our support department, they look in the station logs and they say, power meter failure. They know exactly what's gone in it. They send someone to the station only to replace the power meter, and test it, get it going, and test it again, and then they know they fixed it. So that's the trick with supporting these stations. Sometimes you do have to send someone to the station, but then they know what's going on with the station. They don't have to spend the day there. So this is the final test. Now, this is really to say, I now have done it. Now, say it doesn't work, huh? You can call support, but of course, yeah, you want to try to do it yourself, huh? So there's tricks and troubleshooting techniques that you can follow. And you saw some of those when you were in the video as well. You know, if you measure across the phases, it should be 400. If you're measuring neutral to the phases, it should be 230. Remember, plus or minus that 10%, huh? And any of these, you know, things that you can go through, and these are all in the manuals, huh? Step by step, what you need to do. If you go through this and it's still not working, then reach out to support. Because remember, support sees a lot more than you do, huh? They can see into those logs. They can see everything that you can't see. So reach out to support if you need that. So just to summarize on that, because we need to get into the hub satellites, got to make sure we have enough time for that, because that's really an important part of it. But if you're installing, say, a single station or maybe a double line, huh? The procedure, whether it's hub satellite or not, huh? Installation, we talked about that. Yeah, the civil engineering and the lifting of the station over, that's a very small part of it, huh? But it's physically a very big part of it. But for our perspective, it's a small part of it, huh? Then you configure the station. That means that using that app, huh, to make sure that you set the maximum current, you connect it to the Wi-Fi, and then you test the station, huh? And then you test that station by using a test box or using the customer's car, huh, to test it. That's always better if it's a residential station, huh? Then you know that it's especially worse with the car. And then you can confirm it on the back end by calling support. So to say, if you're worried, if you think something went wrong, or if you know, just worried that it's not, you can call support and say, hey, I've just installed this station. This is the station ID number. Do you see it on the back end? And they'll say, yes, I do. And you did a very good job and everything's fine. And that's just affirmation that things are, confirmation that things went well. But I'm telling you, if you get to that part where you've charged it and it turns blue, you're pretty much all set. So this is the important part of the training, how where single stations are one thing, but the trick and the reason that this is a EVBox legacy is because of our hub satellite configurations here. And there's many different benefits to this. And then let me just talk about those. So what we have is we have a system of charging stations, what you have in all a pretty close proximity, huh? Parking garages, parking terrains, huh? Outside in your parking lot at work, or parking garages. And you have several different charging stations connected to each other. And there's reasons we do that. Here we have up to 20 connectors. Remember, what I'm showing here are double-sided stations. So there's only 10 of those. That's 20 connectors. And then the hub too. Remember, these are all individually hooked up to its own power source, with one of those MCBs per connector protecting it. As we say here, 20 up to 20 connectors with including the hub. So we have one hub, and we have the rest are satellite, what we call satellites. The hub has a modem in it, and the satellites do not. And you can imagine what that means. A modem costs money, and not only money, but a pretty good percentage of an AC station. I'm not going to talk money now, but let's say 800 euros for a station, and 150 of it is the modem. Well, you can imagine that you get savings of per station only having one modem and the rest being satellites. So you can see the savings there. So how do we do that? Well, you can imagine how we do that. We connect all these stations with a data cable. And in this case, it's just an RS-485 cable, data cable. This is where the trick is, that we've got to be careful when we're setting this up, is that RS-485 has to be attached properly. But this allows us, these stations, to talk to each other. They talk to each other and they have communication with each other, and they know who's on the station, how much they're charging, and they can manipulate all those values. We'll talk about that in a second. So this hub, remember also the hub has to be on the left side or the right side. It can be an L, but not a star formation. And the hub can't be in between two satellites. It has to be either at the beginning or the end. That's always, it says it in the manual, so make sure that you remember that. because that is a very important part. Huh? So this, the data cables we use, this is important too. Huh? We use a special data cable. Remember these cables, if I look back here, huh, it looks like these cables go actually over the ground, but of course they do not. They go down into the ground with the power cables. And we know when we mix data cables and power cables, we have something we call electromagnetic interference. And so we don't want that. Huh? We want our data to be sound and clear. So we have a protected cable. Huh? It's just what we call SFTP, shielded, foiled, and twisted pair. Huh? So it twists so that power electromagnetic interference doesn't disturb it. So that's important to make sure that cable, because if you use a regular data cable, you'll have problems with it, with the data communication. So it's important to have that. And we also provide a 120 ohm resistor that we put on the last station. And what that does is that just helps us determine what that last station is, because if there's, say, 6 connectors, we want to know what the last station is. So we provide that connector, that 120 ohm resistor. It's a little tiny resistor like you see, you can find anywhere. So if you open the bag and it falls on the ground, good luck, because you'll never find it again because it's so tiny. But it's just a regular 120 ohm resistor. You can get it anywhere, and you'll see that it goes right into that RS-45 data port connection, which we're going to talk about now too. So to connect these stations to each other, we have a data port in the station. We connect this RS-45 from one station to the next station to the next station. And remember, they go down through the pole into the cables and then to the next pole. And so that's if these aren't connected properly, it's not going to work. And these RS-45, you have to put them, the connectors on yourself. It's also polar. You see here, BA, data communications polar. So if you switch ones upside down, it's not going to work either. And what's going to happen is you're doing these data, and if the data communication is wrong, it'll flash red too. Remember that. When you're seeing flashing red, that doesn't mean that there's anything wrong with the station. It means there's a communication problem. The card doesn't work. It hasn't been activated, or the data cables are not performing properly. So I'll show you a little film on how to do the data cables up. And also remember, I'm only talking G4 here. G3 is completely different, so you'll really have to reference our manuals for that, because I can't go into that right now. If you ever come to do a live training, I'll be very happy to talk about G3 connections as well. So here it really is a simple, this black two-polar connection. It's the only black two-polar connection we have in the station. So it's hard to miss. So if you're saying, where's the data port? Well, it's pretty easy because it's the only two-polar black one. And again, it just has to make sure that it's polar. So let's just look at, I think it's a little video here. Oh, no, I just wanted to mention the 120 ohm resistor that we supply. Oh, let me see. I think this is a little video. Yeah, here. So you see on the right, that's the hub. I'm sorry, that's the satellite. Left is the hub. It has connection with the internet, so it's green. Now, until I connect them, that's going to flash red. As soon as I connect it, it should go to green. So if I'm attaching these, and I'm just going to show you where that port is that I was telling you, that's that two-polar data port. Very simple. Now, I'm not using the SFT cable. I'm just using the regular cable. But you see, as soon as I hook it up and I connect them, they're together. So it is very simple. But you can imagine if that's just loose, if I would have reversed those poles, it wouldn't work. It would stay flashing red. So just make sure that you keep that in mind if you're doing, let's see. Okay, now on load balancing, we're talking about the setup and the data cables, but this is really the trick to all this, and this is something that's utilized everywhere that we sell this product. First of all, I want to talk just about load balancing in general. Load balancing is something that we have in our firmware, and all our competitors have it too. We all do the same thing. In this certain case, this is a typical case of a public station where I have a double charger, and it's capable of putting out 22 kilowatts on both sides, left and right. What that means is with one car, I can charge at 22 kilowatts. but I'm only putting a total of 22 kilowatts on there, in there, huh? Although if I wanted both sides to do 22, I would need 44 kilowatts, huh? So I don't want to put 44 kilowatts on it because I don't want to be wasting energy, huh? So I want to conserve our energy. I want to optimize our energy. So what happens? What do we do? And this is a very simple case, huh? If I am my first car here and I'm the only one charging here, I can get up to 22 kilowatts, huh? Which means that if I'm a Tesla or Zoe, I can get full power, huh? As soon as someone comes and charges on the same station next to me, I split the power very simply in half, huh? And one side gets 11 and the other side gets 11 too, so that we can share that, huh? Now we know in this case, and that's why it is in many cases in the public sector, that most cars can't take 22 anyway, huh? So only 1% of cars on the market today can take 22. So why would you have 22 on both sides when you're not going to ever use that? We're talking about the current situation. Remember, in 5 years, that's all going to change. Batteries are going to be getting bigger. These onboard chargers are going to go from 11 kilowatts to 22 kilowatts so that they can charge in 8 hours. I talked about that limit, of 8 hours. So these things are going to change. So this is something that is kind of future-proof too. But when it comes to our hub satellites, it's even more interesting, huh? Because if you think about a parking garage, huh, we have two different scenarios with parking garages. One is an airport, huh? And a very good example is our airport here in the Netherlands called Schiphol. And of course, we have tons of these charging stations, thousands of them, inside under the in the parking garages there, huh? But that's a kind of a different scenario. I come to the airport, and I'm going to be there for a while. Huh? I'm flying somewhere else, coming back in a week. My car isn't going to be moving in and out. Huh? But our parking garages in our cities, in our daily life, our parking garages, like at my work, like at a shopping center, like at the doctor's office, where people come, people go, people come, people go. Sometimes it's full, but very rarely is it totally full, huh? Sometimes it is. But what we want to do is offer an optimal charging situation for those cases. So I'm going to start with my story because this is the story, and it is the story that we have with all our customers, huh? And that is, I've just purchased these 12 stations, huh? 6 double lines, and I want to power them. So the customer comes to us and says, how much power do I need to power these stations? Well, they're all 22 kilowatt stations. So to power them all, that means when everything is occupied, we need 264 kilowatts, huh? That we translate that to amperage, but in this case, I'm just going to keep it in kilowatts because, of course, this guy is going to say, well, listen, I also have a business to run. I need that power for my machines in my building, for my restaurant, for the lights, for the air conditioning. Yeah, so I can't give you 264. How much can you give? Well, in this case, he's going to say 132, and you can see where I'm going with this, huh? It's a nice even half of what you do. So what happens when I have this? Well, when I am a user, huh, I come into the garage, I'm the first one there, I charge at 22 kilowatts, if I can take it, huh? Second car, 22 kilowatts. And you see where I'm going with this. All these cars are now getting 22 kilowatts because I have now I'm at my peak. So that means now I've used all the power I need. Now I have to start distributing that power. But what happens is when a next customer comes, attaches, it drops to 19 because that's 7 divided by 132. And then we just keep reducing until it's full, huh? When it's full, we have 11 kilowatts per connector, huh? And yes, that can be acceptable, huh? Even if I have a one-phase car, I'm still getting 3.7 kilowatts into my car, huh? So with my small battery, it probably is giving me some, huh? And the important thing in these garages, they're not here to charge your car fully, huh? They're here to top off your car. So a lot of these people are coming and going, and when they leave, if they have more than they came in, they're happy, huh? So I'll show you another scenario where it's very limited, huh? But this limited power, this enables us to use very limited power and make everyone happy, huh? By doing it like this. Now, smart queuing is a little bit different. Huh? This is very, very limited, but this does happen quite often, especially here in the Netherlands. Huh? We have these little garages, huh? These little, or a doctor's office, huh? And they don't have much power to work off of either. So if I have this situation where I have 5 connectors now, but I only have a total of 17 kilowatts, that's 25 amps. Huh? Now, total between all these 5 cars, that means that's very low power. Huh? So what happens is these 4 cars, when they come in, I'm going to be able to charge because I have enough power to start the charging. Huh? It's very slow. Okay. But what's going to happen is when this guy comes here, the last guy comes in, if I divide that 25 amps by 5, I end up with 5 amps per car. Cars start charging at 6 amps. So this is too low. Huh? So this last guy that came on, he'll put in his card, he'll swipe his card, and it'll flash red. And he won't know why. It's just going to be rejected. Huh? He's not going to be happy. I can tell you, people that when it goes to blue, it doesn't matter how fast it's charging. If it goes to blue, they're happy. If it goes to red, you've just destroyed their day, huh? They were just planning to go to the supermarket for a few seconds, and now they're going to call support or talk to somebody. So what do we do here in these situations? We have what we call smart queuing, huh? So that means because we don't have enough power to start this car, we need at least 6 amps. We'll stop one of the other charging sessions, and I showed that in that diagram with the control pilot, huh? That we can also stop a charging session, huh? And then this would be one of those cases, huh? So we put this car, and why do we choose this car? Well, this car was the first one that came into the lot, huh? Not the highest state of charge, although it shows that on the diagram. It's not really the highest state of charge. It's saying you're the first one came, so we're gonna stop you first, huh? After 15 minutes, we stop the second car that came in, and we alternate until everything's good, huh? If you get below this, first of all, you shouldn't be getting below. First of all, you shouldn't even be doing this, huh? Because what you're doing is you're kind of telling customers, yeah, you'll get a little bit of charge when you come, but it's better than no charge at all, I suppose. Huh? So that's hub satellites, huh? And that's also going to be changing in the future. But that is our legacy. That is EVBox, huh? And that load balancing is something that's very important. One of the other important parts of hub satellites, I'll go through this quickly, is phase rotation, huh? And we talked about this in 2 ways, huh? We talk about doing phase rotation physically on the station, and then also putting that into our software so that we know what phases have been rotated. So why do we phase rotate? Well, we talked about cars from Japan and the US on one-phase cars. So a lot of our cars, not only Japanese and American cars, but also a lot of European hybrids, huh? Because the batteries are pretty small, they charge also with one phase, huh? So if you have all these cars coming to your charging stations, these hub satellites or these parking garages, huh? And everyone's pulling off the first phase, you can see where the problem is there, huh? So we have these, if we have all these stations set up where L1, L2, and L3 are all put into its place, that means everyone that, if they happen to be, remember, I'm going to throw out a statistic, don't hold me on it, please. Let's say 80% of all cars on the market are phase 1, so that's a lot. So that means the chances of you having a lot of phase 1 cars are going to be pretty high. So what you want to do here is you want to rotate those phases so that the first one will pull off the phase 1, and then the second one will pull off phase 2, and the third one phase 3. Now, if you're charging in 3-phase, then it doesn't matter, huh? So these will all work. So how do we do that? We do that in this way, how there's sort of a designation system. For you guys as installers, it's very simple, huh? L1, L2, L3 in the first one, huh? And then L2, L3, and then L1, huh? And then you alternate it. And you can alternate it really 3 times. You can do it 6 times, but there's no effect. I've just found that out, that there's no effect for 6 times. So what that means is that you're going to switch, and I'll go through a couple examples. But when we put it into our software, we do it a little differently because we've noticed that there are mistakes have been made. So we use an RST designation, huh? And it's very simple to know that R is phase 1, S is phase 2, and T is phase 3. And that's just to make sure that we know the difference between the wires and the installation block, huh? And this one does a little bit better of a job, huh? So you see the phases, huh? In Europe, phase 1 is brown, phase 2 is black, and phase 3 is gray. So in the first one, you're going to do that 1, 2, 3, and you see that on the connector here, reference phasing. So that's just RST, 1, 2, 3. And the next one, you're just going to do 2, 3, 1, So STR, we call that 120-degree rotation, and then TRS. And that just gives, and then if you repeat that, now you can do this because if you know, with the numbers, you can get certain amount of combinations, But I've been told, because I've been presenting this for quite some time, but one of my engineers came and said, listen, those last 3 don't really make a difference, So you can just tell them to do the first 3 and then repeat after that, If you do the rest of the 6, it works perfectly as well, But what's important is it does make a difference, Of course it does, because like I said, you're not pulling off that first phase. But it's also important to relay that to our people inside. You can also put this into your into the EVBox Connect app. How you can do it yourself to say, I did it RST, and they'll show you how to do it. But like I said, and again, I get in trouble for saying these things, but I really think installer doing it physically is fine. You write it down somehow, saying 1, 2, 3, 3, 2, 1, 2, 3. And then you send it to us and we put it in the system. Either way, we want to put it in the system. So if you do it on the app, fine. If not, please call support and give that documentation. You can just take a picture of your notes and then just send it to them, and then that support people will put that in. But that's phase rotation, and it is important, because like I said, we have a lot of phase 1 cars out there. This is how to put it in the system. I won't go through this because it's not relevant to you, but this is the way the support people would do. We have a configuration tab, and they just go and they say phase rotation, and then there's a certain procedure they need to put into there. That's also put in. I'm not going to go through that. Okay, so let me see where we're doing at time. Yeah, good. Spare parts and service. Okay, just to say, spare parts, we're going to talk about it, and then the support as well, and maintenance as well. So this is the G4 station. I showed you the G3. We have the exact same diagram for G3. So if you ever have a G3 station, you need to service that, just make sure you download that, the diagram from the G3, and then it gives you all the different part numbers. So this is a modular device, so that means that any of these pieces of components can be replaced. So as you need to go to the station to replace these components, this is how you do it. And again, you don't go blind to the station. Our support department or a support department will go and say, hey, listen, we see in our station logs that the control control box is defective. Could you please replace it with another one? Send this back to us. We have RMAs that take care of that, whether it's on the warranty or not. But you see all the other components, like the lead ring, can be replaced. You see that those components are replaced sometimes quite often. Remember, with the lead ring, the LED ring, it's non-functional. So if it doesn't work, doesn't mean that the station doesn't work. The station works fine. So that's why, sometimes you have to put that priority in. But these components are all available to us. These are the part numbers. These documents are also available to you as well. Just a quick look inside. This is the G4 I showed you earlier, with the communication module in there like that. We have an RCBO that checks against, of course, our AC leakage and our overcurrent. And we also have a CCID in there that I don't have on here, but it's a CCID that checks for the DC current, plus all the other communications that aren't necessary. One other thing I just want to mention, and this is something too that I've added to, because this is a UK regulation that's not really doesn't apply to the Netherlands or Germany or anywhere else. This is what we call OPEN, and you may be familiar with this, but this has to do with safety, with the fact that in England, the neutral and the ground are attached to each other in some circumstances where you need to add a different device to it. I'm told from our technical people in the UK that this really pertains to the residential stations and not necessarily the business line stations. If this is the address that they gave, the URL with information on this. This will be in the slides I send to you, so if you ever need to reference it. And if you have any questions, when you call into, I'll show you the support lines later. When you call into the support, it's going to be UK support, so they're very familiar with this. But as a manufacturer, because there are so many different regions that we sell into, we don't pay a lot of attention to that. But I was going to just make sure I mentioned that. Okay, so now reaching out to support. You know, like I talked about remote support, huh? We have to utilize that. That's why calling in, and don't try to do anything, you know, everything yourself. Huh? We have the support. Remember, they have access to all these stations remotely. So always, if you get into questions and you don't know where to go, call the support. You can work on it together and say, I see this, you see that. Huh? You're on the field. That's also important to us. Huh? You're there, and we're behind the computer helping it. For some of you, we have the EVBox partner portal. Our partners, EVBox partners, have access to this, but it is a login, huh? So you have access to all our. You can also escalate cases in the partner portal. If you are working a company that does not have access to the partner portal, please reach out to us, because you know we want you to be a partner of us, and when you are installing our products, we want you to be informed as much as anyone else. As far as the on-site support, that is very dependent on the situation, huh? So a lot of you as installers might even be sent for that on-site support saying, could you go to this station to replace a component for us? Could be that you installed the station and somebody else does that online support. So that depends on what our support network decides in that case. If you do use the partner portal, I'm not going to go through this whole thing, because this is it's also just like that EVBox Connect app, huh? It's very intuitive. So they'll ask you the questions that you need to do. So I won't go through this. I'm working on a training for this too. So in the future, you'll be able to just download a little video showing how it works and everything like that. So it's very simple, but it's a login, and it helps when you're looking for information. If you do not have access to the partner portal temporarily, like I said, I think you should. This site is open for everyone, so it's public, and it has also knowledge bases. You're also able to reach out to support using this network as well. Huh? Just quickly on maintenance. Maintenance is something that is done in our manuals. If you read the manuals, you'll see it's really the responsibility of the owner to do that maintenance. Huh? What does that mean? That means yearly checks, the visual checks to make sure that the cover's on, that it's not broken, that there's no dust particles in the socket, et cetera, et cetera. Because remember, these are remotely monitored. So if there's anything wrong with it, we're going to know about it anyway. So we do these yearly checks out from the installer. Your customers might ask you to do that for them. Huh? Can you come back? Can you come around once per year and check all the stations in my parking garage? I would say it's a good idea, because some of the owners don't take that seriously. And I've been to many garages where I've opened a connector and I see leaves and things in there, so it's not good. I talk a lot about support, huh? We don't want to be inundated with calls from installers, of course. We don't like that, but we also want people to be installing stations properly. So reach out to us if you need to. Try to solve the problem yourself, but also, especially if you're new, then reach out, and then you learn from your from the experience you get with us. Huh? This is the number, huh? So if you need to reach out, that would be the number to call. I'm hoping that that's still the same number. That they haven't told me to change that. If not, you'll be able to find it. We have it on our website there too. I'm going to ask you to do something very quickly for me. There's two things actually. Could you do me one favor? This is a QR code with a survey. And we just want to know if there's anything that we can do to improve this type of trainings. So what you need to do here is, if you have a QR code scanner, if you could scan this and fill out that survey. It only takes 1 minute. It's only a few seconds of your time, and I really would appreciate that, because it's helpful to us. I can't tell you how much it's changed since we've getting these, because we get a lot of comments. I'm going to shut up and let you do it. Yes, EV boxers can do it too if you want. But I'll know who you are. Okay, and then the other thing, if you're not done, just ignore me. But it's another thing is just the attendance. I'd made a couple notes of some people that I saw, but if you could just, if you're attending, could you just put in the chat your name? Just write your name in the chat. If you're in a group with others, could you put your name in there too? All the names so that I know exactly who was there. And it doesn't really matter. These are free trainings anyway, but we just would like to know who has attended for our commercial people that signed you up. Thanks, you guys. Really appreciate it. And you know, and this is really kind of rare that we actually have this time at the end because sometimes I rush it and we just don't have any time for questions. So I'm going to open the floor to questions, and please don't be shy. There are no stupid questions. Even if you have an experience or something that you want to share with us, if you've installed these and you say, yeah, actually, Joe, what you're saying is all crap because I've done this before. It doesn't work at all like that. Huh? Now it's the difference between practical and theoretical work. Huh? Anyone with a question? EVBoxers too can ask.
Quick question. Hello, can you hear me?
Yes, I can. Thanks.
Yeah, can you link two hubs together? On the job we're doing, we've got two hubs and a series of satellites. Can you link the two hubs together to limit the amount of current we draw?
Well, if you want to link them together, like with a data cable, huh? Then you need to use a satellite for that, huh? Not for a hub. So you can't necessarily link two hubs together and expect them to work as a hub satellite, if that's what the question is.
Yeah, we've been sold one 3-phase hub and two satellite 3 phases, and one single-phase hub and 8 single-phase satellites. So they're all in the same spot. We've got a limited amount of power. How do we limit both hubs without limiting to them?
In that case, that means we're setting up two different hubs, huh? So you're going to have one hub for 3-phase and one hub for 2-phase. I'm sorry, for 1-phase. But I believe they'll be separated, huh? So
they're on the same source, and we've only got a limited amount of kilowatts on that source.
Well, you know, you can do that if you replace, you know, that it's only that hub that you need to not to use. So in other words, with that one hub for the 3-phase, huh, you can connect all the rest being satellites. But I wouldn't throw in a single phase with a modem in that mix, because then you'll have interference with the data. So in other words, so if I have a 3-phase hub, and I do a 3-phase satellite next to it, and then the rest are all single phase, that can be done, huh? But remember, only up to 20 connectors total.
We'll be over the 20.
How many do you have total?
24.
Yeah, so then that's probably why they said, listen, it'd be best to have that in two different hubs. And two different hub satellites with that. But I mean, if it's from the same power source, that shouldn't make a difference. But it's just load balancing that will only happen per group. Huh? So I think that's the case, is that you have too many satellites. Huh? We don't recommend going over 20 connectors. And that's probably why you have one hub for a single line. And yeah, I mean, it would make sense to, I mean, it depends on how you want your infrastructure to be used. But like I said, 1-phase, if there's a reason for those 1 phases and not to be mixed with the 3 phases, but I'm not sure if that's the case. I hope that that might be enough. And if it's not enough, get in touch with. That's why our FSPs. We have a guy in the UK called Ray that was just here last week too. He can also help you. So reach out to our support department if you have questions, because it sounds to me, when we have these questions like this, is when our commercial people are doing these, they'll say to the people, hey, listen, we have 24 stations now. We want you to split it up into 2 different hub satellites. And that's the distribution would be simple with 3-phase versus 1-phase, but it depends on the customer. Anyone else?
Yeah, I have a question.
Sure.
Actually, it's on the slide. It's actually a confusion on the slide 41. I saw something about the hub satellite.
Yeah.
Yeah. What I understand is that what we can do with the hub satellite is that it helps to manage the power actually. And I saw in the slide that it's mentioned that each station use its own power source.
Yes. Which means that each connector, not only each station, but each connector has to have a separate power connection. So that means a MCB protected going into the station, huh? Not from original power source, but just, in other words, if it's a 32 amp station, that you have a 32 amp circuit breaker, an MCB, on each connector. That's required.
Okay, I see.
Yeah, but
So
I think what they're talking about is the original power source. Huh? When you're talking about multi-stations, then you'll have a circuit breaker also of say 240 amps that will secure the whole grid, huh? But also individually, you want the 32 amp circuit breaker or 16 amp, depending on what you're using.
Okay, I see.
Okay.
Yeah, it's clear. Thank you.
Yes. Okay.
One question, like in real situation, if we connect more than 20 station, like the other person said, so what would be the problem happen?
Yeah.
Like there is
That's a great question. I love those questions because and I tell you, if you ask anyone else, they'll probably not know. But because I've been here so long, I've witnessed it. Yes, you're absolutely right. I've actually seen one with 24 that had no problems, huh? But I've seen a lot more with more than 20 that had problems, huh? So it is one of those situations where after 20, the data starts getting tainted somehow. So what we're saying is we limit that to 20 so that we can eliminate any potential problems in the future. And so but we'll see in our new devices, not that matters to this training, but our future devices will be unlimited, huh? So you'll be able to actually put as many stations together as you want. So that limiting factor is not going to be there. But in this case, that's the case. You're absolutely right. And like I said, it would be interesting to do an experiment, huh? And set up 24 and say, hey, Joe, it works perfectly. What are you talking about? But remember, in the manufacturing, it works. It's got to work all the time. It's got to work all the time, not even 90% of the time. It always has to work. Otherwise, what we do when you have 100,000 stations in the field is you just get inundated with calls saying, this isn't working, that's not working. So these are the things we do to make sure that those calls stop coming in. And one of those is limiting the amount of connectors that go to.
Okay, right. But last thing, in this situation, if something happen or we try to practice this thing, so the problem start to happen in all the stations or only the last station that is over the 20?
No, it would be the data communication, and it can happen anywhere, huh?
Okay.
It's the same thing. That's a good question, because what I want to reference to is that if you do have a problem, say in a middle satellite, huh, that does affect the rest of the string, huh? So that's why those data, really the data communication cables is what's really important to get those right when you're doing these setups, huh? Because the cables themselves are easy to do, but that data cable has to be set in properly, and the RS-45 is not a great connection, but you'll see that too, just to emphasize that it's important to do that properly. Anyone else? And remember, that doesn't mean that you can't ever ask any questions, huh? I don't know the experience from you guys. Some of you may have already been in the field. From what I see, it is the case, huh? Please use us. Please use EVBox. Me personally, myself too, huh? We're gonna send you this information. So what you're gonna get is a copy of the recording, copy of the slide deck, huh? And then if you have any questions about the training or anything else, reach out to me, reach out to one of my staff, or reach out to support. That's probably the best thing. We have some of the best support people in our whole global communication. In the UK, a guy named Matt Draper. Oh, I shouldn't mention his name. You're going to call him all the time. But he's really good, really knowledgeable. So if you have any questions, reach out to them, but reach out to us. But use us, huh? That's how you gain experience. Use the website, use the documentation. You know, don't call us for every little thing, but just make sure that you reach out to us if you need it. Okay. Anything else before we go? It's been a pleasure, you guys. I really appreciate you guys taking the time to come and listen to this, huh? Because it's not you know, mandatory to do. But I really appreciate it because I hope it helps you in the field and helps eliminate some problems that you experience. And I appreciate your patience with the training. And again, reach out if you have any questions. Okay. Thanks, you guys.
Okay. Thank
Have
you.
a
Bye.
great day.
Take care.
Thank you so much.